So for number 7, again, this one is in vertex form, so we know it's going to open up, therefore there will be a minimum, and the vertex is opposite of inside, so it's -5, comma, number on the outside, -3. If we know that this is our vertex, x equals -5 is our axis of symmetry, and our min value is just -3, because that's the y-coordinate of the vertex. You can use your calculator or plug in any numbers that are smaller than -5 and bigger than -5 to get the shape of the graph. Number 8's intercept form. So we see 1/2 in front, so we know it's going to open up. Our vertex is going to be a min. And our intercepts, our x-intercepts, are going to be opposite of inside, because when we set our parentheses to 0, we get opposite. So we'll get +5 and -1 as our x-intercepts. To find the x-coordinate of the vertex, we add them, and we divide by 2, which will get us 2. And once you get the x-coordinate of the vertex, you plug that in to the original equation for x, and you get your output, your y-coordinate of -4, 5. So now we have our intercepts and our vertex. The axis of symmetry is the x-coordinate of our vertex. X is 2. And our min value is the y-coordinate of our vertex, -4.5. 9 and 10 can be a little tricky. Just remember that you do not distribute the -2. You need to use order of operations. You need to first rewrite x minus 5 squared as x minus 5 times x minus 5. Once you multiply that expression, you end up with x squared minus 10x plus 25. You then distribute the -2 into that expression, because you're multiplying the expression by the quantity in front, and you end up with -2x squared plus 20x minus 50, and then you add on that 3 at the end, and when you simplify, this is your expression in standard form. Similarly, in number 10, you first FOIL, so we multiply parentheses sets, and we're going to leave it in larger parentheses. We simplify, we get x squared plus 4x minus 12, then we distribute the half, and we end up with our final answer, y equals 1/2 x squared plus 2x minus 6. For these word problems, remember, finding the vertex is critical, even if you have no idea what to do. It says a mouse jumps in the air, and then it lands. So to find the height of the mouse, the height, first of all, is the y-coordinate of the vertex, right? This x, the 3.25, is its distance out. But the height that this mouse jumped was about 2.1 feet in the air. We found the vertex by doing -b over 2a, because it was in standard form, so that got us the x-coordinate. Then we plugged that in for x and found the y-coordinate. Therefore, our vertex was 3.25, comma, about 2.11. And if y is the height, and the mouse only jumped about 2.1 feet in the air, and the fence was 3 feet. That's the fence, and it's 3 feet. The mouse is not able to jump over the fence. When you're looking at the kangaroo problem, again, vertex is critical. Well, this problem's in vertex form, so it's very easy to find the vertex. Vertex is opposite of what's by the x, so positive 52.5, comma, number on right, 45. Okay, what do we do with the vertex? Okay, well, we know that the y-coordinate is the height. So we know that the kangaroo jumping, the height of the jump is 45, and the units they say is feet. The x-coordinate is how far out to that halfway point we are. So we're 52.5 feet out. So the question is, what's the kangaroo's maximum height? So again, max is the y-coordinate of the vertex, and you know y is also the height. So the kangaroo jumped 45 feet in the air, and then how long is the kangaroo's jump? That's a little harder. Well, look at it. If the x-coordinate of the vertex is 52.5, at the halfway point, the kangaroo's jumped 52.5 feet out, then you have to double it. And when you double it to get the full distance, you end up with 105 feet. This is where it lands, right? It's halfway out at 52.5. So it's full way out at 105 feet once it ends its jump.